Hello friends, today is the second lecture of our calcium metabolism series, and today we are going to discuss about the bone physiology. Now you know that the bone is basically the one type of the connective tissue, right? They are basically very rigid. That's why they are known as the rigid connective tissue. And you know the different type of function that is done by bone. They basically they protect the vital organs. They give the rigidity. It provides the movement, basically the locomotion, and support the load against the gravity. Now all this function is done by bone because it has a two type of strength. One is a tensile strength, another one is the compressive strength. Now what are those strengths? Let me show you one picture so you can easily understand that. Compressive strength basically to compress the bone, and tensile strength basically to tense the bone. Let me give you an example of both of them. As far as the tensile strength is concerned, it will be the hanging at the bar. It will utilize the tensile strength of the bone, and the weight lifting, it basically utilize the compressive type of the strength of the bone. Now both the type of the strength will be given by extracellular matrix. Got it? Now what is this extracellular matrix? Let's understand this thing. Extracellular matrix is made up of two things. It has a two component. One is the organic, another one is the inorganic component. Now as far as the organic component is concerned, they are made up of the collagen fiber. If you are thinking about which type of the collagen, it is type 1 collagen fiber, and that collagen fiber obviously it gives the tensile strength of the bone. And the remaining one is the inorganic component. That inorganic component will be made up of calcium phosphate crystals, and that crystal will give the compressive type of the strength. Right? Now the calcium in the bone, this calcium is situated inside the bone. Basically two type of the pool that are basically present inside the bone. One is known as a readily exchangeable pool, another one is known as a stable pool or slowly exchangeable pool. Right? Now what are those pool? Readily exchangeable pool can readily provide a movement of the calcium in and out of the bone to the plasma and plasma to the bone. So it makes the calcium to move away from the bone or inside the bone very easily. That's why it is known as readily exchangeable pool. And the amount of the calcium that move per day is 500 millimole per calcium per day in and out of the bone. And the remaining one is the stable calcium. That stable calcium or slowly exchangeable calcium is involved in bone remodeling, and that bone remodeling will be done by constant interplay between the removal of the bone and deposition of the bone. Now what is the bone remodeling, what is bone reabsorption, what is deposition, that we discuss in our subsequent slide, so don't worry. And the amount, if you guys are wondering that how much amount of the calcium will be moved in and out from the stable calcium, that amount is 7.5 millimole per day. In case of readily exchangeable pool, it is 500 millimole per day. In case of the stable calcium, it is 7.5 millimole per day. That is not written inside the slide. Now the percentage. Now we know there are two type of pool that is present inside the bone, but how much percentage of the calcium is present in each pool, right? So out of the total calcium that is present inside the bone, 1% of the calcium is present in the exchangeable calcium, and the remaining 99% is present as a stable calcium. Now inside that bone, calcium will make a crystal with two things. One is Pi, Pi stands for the phosphate, and another one is the hydroxide ion. Remember the exact term, it is hydroxide ion, not hydroxyl. Hydroxyl is a different thing that we discuss in our steroid lecture. Right now remember that calcium make a crystal with phosphate and hydroxide ion, and the compound that is formed by calcium plus phosphate plus hydroxide ion, that compound is known as hydroxyapatite. and the chemical formula it is written like this: calcium 10, phosphate 6 and hydroxide 2. Got it? So this hydroxyapatite is not only calcium and phosphate, it is calcium plus phosphate plus hydroxide ion. And the ratio of calcium and phosphate is basically 1.7:1. Alright. Now there is one comment might be asked from this slide that I recently came across in the book named Sirkar. Why hydroxyapatite does not precipitate in extracellular fluid despite supersaturation of the calcium and phosphate ion will be present inside the plasma? So the answer of that question is like that: in plasma as well as all the tissue except bone, there are inhibitors present. That inhibitors will inhibit that precipitation of calcium and phosphate, right? So the answer will be look like this: inhibitors are present in almost all the tissue of the body as well as plasma to prevent such precipitation, and the name of that inhibitor is pyrophosphate. The name of that inhibitor is pyrophosphate. Now let's discuss the different types of the bone cell. There are different types of the bone. There are basically two type of the bone, as you guys already know from the anatomy. One is the compact bone and another one is the spongy bone. Compact or the cortical bone and trabecular or the spongy bone. Now you can see from in this slide that compact bone it is present over the outer region. It makes the outer layer of the bone, and it is basically 80% of the total bone. And the spongy bone it is situated inside that cortical layer of the bone or compact bone, and it is remaining 20% of the bone will be made up of spongy bone. It comprises about 20%, and the spongy bone is metabolically more active from the compact bone. Got it? Now this term more metabolically active, it means that the calcium in and out movement will be taking place more in the spongy bone, and this compact bone is receiving nutrition from the Haverson canal that we discuss in our subsequent slide. Now let's discuss the different type of the bone cell. There are three different type of the bone cell starting with the first, osteoblast. You see in this diagram the osteoblast, this small set of the bone that is situated at the periphery are the osteoblast. They are basically bone forming cell. Another cell is the osteoclast. Again, the cell that is present over here, the biggest cell in the bone, it is osteoclast. They are removing the bone, so known as bone removing cell. And the remaining one is the osteocyte. Now you can see that osteocyte is present inside this structure, while the osteoclast and osteoblast are present at the periphery. Now once the osteoblast become entrapped in the osteoid and then it become osteocyte. Now don't get confused that what is the osteoid, how they become entrapped and become osteocyte. We are going to discuss in our subsequent slide. Now right now remember just the definition: osteoblast bone forming, osteoclast bone removing, osteocyte it is basically the osteoblast that become entrapped in the osteoid. So osteocyte are the osteoblast, but they are entrapped somewhere, right? So this osteocyte are once osteoblast, क्योंकि सास भी कभी बहू थी, right? These osteocytes are once osteoblast, but then they become osteocyte, right? Now let's discuss these three bone cell one by one. Osteoblast. Osteoblasts are the bone forming cell and they are mesenchymal origin, basically the fibroblast. So fibroblast get differentiated into bone forming cell, osteoblast, and this osteoblast will secrete the extracellular matrix inside the surrounding. Now what is extracellular matrix? There are basically organic and inorganic compound that we discussed already. The organic compound is the collagen, inorganic compound is calcium and phosphate. Now how this osteoblast will secrete the extracellular matrix into the surrounding? Let me give you a picture that you can easily incorporate that picture inside our story. the water sprinkler that you see at the garden, right? What water sprinkler will do? Water sprinkler will sprinkle the water 360 around it, right? So basically you can easily understand that water sprinkler, the black color portion is the osteoblast, and the water that it's sprinkling is the extracellular matrix, basically the collagen and the calcium and phosphate. Right, now here's the thing, once this collagen and phosphate become crystallized and get incorporated inside the collagen, it become fixed, and this water sprinkler will be entrapped inside the water that it's sprinkling actually, right? So that's how osteoblast, once they secrete the extracellular matrix, that is collagen and calcium and phosphate, but once the calcium and phosphate get crystallized and incorporate inside the collagen, that osteoblast cannot perform any function and it become entrapped in its own secret and it become osteocytes. Once these osteoblasts are sprinkle the extracellular matrix and the collagen and phosphate get incorporated inside the collagen, it become osteocyte. So once upon a time, this osteocyte are basically the osteoblast, and it secrete the extracellular matrix, this yellowish portion that surround that osteoblast, this osteocyte, it make osteocyte. Got it? So osteoblast, after secreting the extracellular matrix in the surrounding, they entrap inside that secret and become osteocyte. That's it. So it, now we back to our story. Now this osteoblast, by secreting the extracellular matrix, it make extracellular matrix, and when this extracellular matrix surround this osteoblast, they differentiated into the osteocyte. Got it? Now the osteoclast. You see the biggest cell in this picture is this one, that is osteoclast. This osteoclast are basically the bone resorption cell, and they are derivatives, or they are basically derived from the hemopoietic lineage. If we become more precise, it is derivatives of derived from the monocyte, that we discuss in our subsequent lecture. Right now remember that osteoclast are nothing but a monocyte, and it become multinucleated cell. You can see that cell is multinucleated. Somehow it differentiated and become a multinucleated cell. Now the function of this osteoclast, you can see that it has a direct contact with the extracellular matrix, right? So basically this osteoclast is going to break this extracellular matrix and resorb the bone. So basically it break the extracellular matrix and release the calcium and phosphate, and also release the collagen and secrete inside the blood, and this calcium will be used for various function. Now this function of the osteoclast of removing this extracellular matrix is useful for bone remodeling. Now what is the bone remodeling, that we discuss in our subsequent slide. Now but let me give you a small idea of the bone remodeling. Is that, see, once this portion of the bone gets stressed, it get more mechanical activity, like it become more compressed. This osteoclast remove that portion of the extracellular matrix and and make a space over here. Now that space is invaded by the osteoblast, and the osteoblast will make a new bone by secreting the extracellular matrix and make this portion of the bone even stronger. Got it? So that's how the bone remodeling work. First they remove the bone and remove the extracellular matrix, make a space. That space is going to invade by the adjacent osteoblast. That osteoblast is again secrete the extracellular matrix into surrounding, then it become calcified and make a stronger portion, and once this extracellular matrix will entrap that particular osteoblast, they become osteocyte. Now one more thing, you see this osteocyte has a branches like this. That branches are known as canaliculi, that we discuss in our next slide. See, the osteocyte has a branch, that branch is known as canaliculi, and they have connection with the adjacent osteocyte. So they are talking with each other, osteocyte. They also has a connection with osteoblast. Got it? They also has a connection with osteoblast. You can see in this diagram. But they do not have connection with this one, osteoclast. Right? So to make bone remodeling, this osteocyte first they first make connection, they first give information to the osteoblast. Now this osteoblast by somehow activate the osteoclast. Let me repeat one more time. When we get bone to remodeled, this osteocyte are the mechanical sensor that sense the compression or any other mechanical stress that bone can handle. This osteocyte work as a mechanical sensor and they will give the information to the osteoblast. They have a connection directly with the osteoblast. Now this osteoblast by somehow activate the osteoclast and this osteoclast start bone resorption. Once the osteoclast finish the bone resorption, it make a space over here. That space will be invaded by the adjacent osteoblast and make a new set of bone over here. It secrete the extracellular matrix and it become crystallize and make a stronger bone. Got it? Now let's discuss the osteocyte. Now osteocytes are the more common and more abundant cell and it provide nutrition to the bone. So basically they are connected with the blood vessel and they have extensive processes. That extensive processes that I told you earlier, they are canaliculi, and via this canaliculi they connect with each other. Osteocyte connect with each other and also has a connection with the osteoblast, and they are basically responsible for exchange of the different type of the materials between them. Right? Now here's the thing, the osteocyte are the major regulator of the bone remodeling. So osteocyte has a mechanosensitive osteocyte are the mechanosensor of the bone. When they sense any stress, they send the signal to the surface osteoblast because they have a direct connection with the osteoblast. That osteoblast by somehow recruit the osteoclast and this osteoclast will then perform the bone resorption function, remove the extracellular matrix that is situated just adjacent to this processes and make a space over here, and that space is again invaded by the adjacent osteoblast and perform the new bone formation. Now here's the thing, this is this once the osteocyte has a direct connection with the osteoblast, they not only stimulate the osteoblast, they also produce a substance. That substance will inhibit the osteoblast. So basically negative feedback type of the situation over here. So osteocyte also make a substance known as sclerostin. Remember the term sclerostin. That sclerostin inhibit the differentiation of the osteoblast. Differentiation from where? Differentiation from the fibroblast. So no more osteoblast will be recruited from the fibroblast, right? And inhibit the bone formation. Clear? Let me repeat one more time. Osteoblasts are situated at the periphery. They are bone forming cell. Osteoclast also present at the periphery. They are bone removing cell, and osteocyte are present inside the bone. They are basically the osteoblast. They get entrapped from the extracellular matrix that they secreted. Now this osteocyte are connected with each other via canaliculi, and this canaliculi will be connected to osteoblast as well. But osteocyte do not have a direct connection with the osteoclast. So when osteocyte sense any stress, they have a direct connection with the osteoblast, and this osteoblast somehow recruit the osteoclast, and this osteoclast make a bone resorption and make a space over here, and then there is a differentiation of the new osteoblast. The adjacent osteoblast get invaded over here and make a new bone. That's how the bone remodeling works. This is all about the type of the cell. Now let's understand the structure of the bone. Now I am going to show you a very big picture. Do not confuse with the picture. Just follow my leads. See, you can familiarize with the terminology known as a functional unit, right? The nephron is the functional unit of the kidney. In same fashion, sarcomere is the functional unit of the muscle, right? So bone also has a functional unit. Got it? Bone also has a functional unit. That functional unit that I am going to show you is over the compact bone. Let me show you the picture. Now that functional unit that make the bone are the osteon. Got it? So basically there are lots and lots of the osteon that is situated inside the bone. See, this is the one osteon, this is the second, this one is the third. So osteon are nothing but they look like a onion, right? They are made up of the concentric layer, same as onion. You see inside the onion is made up of concentric layer. Same thing, osteon is made up of concentric layer. If you want to understand the three-dimensional view of the osteon, it is the figure that is present over adjacent like this one. This is again this osteon. This osteon is made up of concentric layer. Got it? This concentric layer are basically the collagen fiber. This is the actual picture, the bigger one. This osteon is nothing but made up of concentric layer of the collagen fiber. Same, this collagen will be secreted from osteoblast, obviously, right? Now inside this osteon, inside this cylinder, there is a canal. There is a central canal. You got that central canal? This central canal contains, you can easily see that there are blood vessels. They also present nerve and lymphatics. So this central canal that is present inside the osteon, it is known as Haversian canal. This canal is known as Haversian canal. You can see there are different Haversian canal in different osteon that is present surrounding this cortical bone. This one is the cross section of the one osteon, right? Now this Haversian canal and adjacent Haversian canal will be connected with each other. That is known as Volkmann's canal. Yes, you heard it right. It is a Volkmann's canal. So two Haversian canal will be connected with each other via Volkmann's canal. Let's get back to the original picture. This is the osteon made up of concentric layer of the collagen fiber, right? Inside this concentric layer there are space. See, these are the two concentric layer. Now in between these two concentric layer there is a space. That space is known as lacunae. And this concentric layer are known as lamellae. So do not confuse with the lamellae and lacunae. Lacunae, as the name suggests, is the space. Now see in this diagram, this onion has a different layer. This one layer is one lamellae. Same fashion over here, there is one layer of the collagen fiber, there is one lamellae. And in between two adjacent lamellae, there is a lacunae. The space is known as lacunae. And inside that space, there is osteoblast resides. That osteoblast is actually secrete that collagen and make a concentric layer, and same osteoblast will secrete the calcium and phosphate and make crystallized form and make a bone mineralization of the bone. Now once this, see, this is the spot, this one is the osteocyte, but this osteocyte is actually once the osteoblast, they secrete the collagen that make the lamellae, and it secrete the calcium and phosphate and make the mineralization, and once they entrap they become osteocyte like this. So basically the osteocyte are once the osteoblast, and that osteoblast will be situated inside the lacuna. Now where this lacuna present, again this lacuna will be present in between the lamellae. Got it? Let me revise myself one more time. Bone is made up of functional unit known as osteon. This osteon are the concentric layer. It is more or less same like onion. That osteon, you can easily incorporate the word osteon and onion. Got it? Now this osteon has a concentric layer of the collagen fiber. Their collagen fiber is known as lamellae. Got it? Now inside this lamella, between these two lamella, there is a space. That space is known as lacunae. And inside that space, inside that lacunae, there is a osteoblast. That osteoblast is actually secrete that collagen and make a concentric layer. And they also secrete the calcium and phosphate and make a crystallization hydroxyapatite. And once they entrap, it become osteocyte. Now let's come back to the center. Inside the center of the osteon, there is a canal known as the central canal. Inside that central canal, there is a Haversian. It is known as Haversian canal, and blood vessel, lymphatics, and nerve are present inside this Haversian canal. Now, two adjacent Haversian canal will connected with each other via this canal that is known as Walkman's canal. Clear? Now, how will you write it down? The muscle has a unit known as the sarcomere. In the same fashion, bone also has a unit known as osteon. That osteon contain a concentric ring known as the lamellae, and space inside the lamellae is known as lacunae. And inside this space, lacunae, there is osteoblast that secrete that secrete the extracellular matrix and eventually become the osteocyte. Got it? Now in the very center of the osteon has a canal. That canal is known as the Haversian canal, and it may consist of the blood vessel, lymphatic, and the nerve. And two adjacent Haversian canal will be connected to each other via Walkman's canal. Got it? Now the confusing thing that we are going to understand in last, the difference between osteon and osteoid. Now, what is the difference between osteon and osteoid? Both are sound similar, but they are little bit of different. Now, what is osteon that we discussed in our previous slide? Osteon is the functional unit of the bone. They are basically the collagen fiber. This is the functional unit of the bone, the collagen fiber that encircling and make a one functional unit of the bone. It is known as osteon, right? Now, the osteon is basically around each Haversian canal. Collagen is arranged in concentric layer and forming a cylinder known as osteon. You can see in this diagram also, this is the osteon. This is the one portion of the osteon. This is magnified over here, and you can see that there is a lamellae, one lamellae. Inside that lamellae, there is a space. That space is known as lacunae. Now in this diagram, this lacunae that is present in between these two lamellae, there is a yellow cell, bigger one. That yellow cell they actually shown as the osteocyte. Now this osteocyte wants the osteoblast, and they secrete the collagen and the phosphorus and the calcium and phosphate and become entrap and become osteocyte. Got it? And this osteocyte has a canaliculi. Got it? Now what is the osteoid? Now you can see this osteon has a round structure, right? And inside that round structure there are different lamellae, and in between these lamellae there is a space known as lacunae, and inside that lacunae there is a osteoblast that eventually become osteocyte. But right now let's understand that this one is the osteoblast. They start secreting the collagen fiber and make a concentric layer. They do not yet start secreting the calcium and phosphate. So that particular portion of the osteon does not yet start mineralization, but they are made up of collagen, right? Let me repeat one more time. See, this is the one osteon. This osteon is made up of different concentric layer. That concentric layer has a different lamellae. Inside that lamellae there is a lacunae. Inside that lacunae there is a osteoblast. They secreting the collagen fiber and make this circular cylindrical layer, but they do not yet start secreting the calcium and phosphate. So the portion of that osteon that it has made up of only the collagen fiber but does not have calcium and phosphate, does not have mineralization, that portion is known as osteoid. So by definition, osteoid is unmineralized organic component of the bone. Got it? So osteon is a functional unit of the bone, and osteoid is unmineralized organic component of the bone. I hope you guys understand this thing. Now in next lecture we are going to understand the bone resorption and bone formation. So do not skip that lecture. It is very much important as far as the mechanism of action of parathyroid hormone, vitamin D, and calcitonin is concerned. Got it? That's it for our today's lecture. Thank you.